Good morning. Today we are going to be working on transformations of parent functions. We are going to focus on absolute value transformations and quadratic transformation. These are TEKS from Algebra 2 and Algebra 1. So in general, parent function transformations, we're going to be looking at what A, B, H, and K cause, the transformation it causes from the parent function. So some textbooks use A, B, C, and D. Guys, that just means that H and C are the same and K and D are the same. For the purpose of this video, I will be using H and K. So general parent function transformations, we have the four variables that do something. A is always going to be in front of the function. Now the function can be a square root, it can be quadratic, absolute value, any function. A is going to be in front of it. A causes vertical stretch or compression, and here are the guidelines for those. And A can also cause a reflection over the x-axis. The B, if you have a B and an H, you must factor out the B, hence the double parentheses. B will cause a horizontal stretch or compression. Again, we always take the absolute value to figure out if it's a stretch or compression, and the amount of the stretch or compression is the reciprocal of the absolute value. H is going to cause the graph to shift left and right, but because there's a negative in the equation, that means that we're always going to change the sign of what we see because it's subtracting it. So when we see -5, we're subtracting a +5, and so it's going to the right 5. If we see a +2, that's really subtracting a -2, so H is a -2, and it's going left 2. H will always be in the parentheses or under the square root or inside the absolute value with the x, okay? K will never be in parentheses. K is always going to be outside the parentheses with the plus or minus. It's typically written at the end, but even if it's written in front of it, if I put -3 plus f of x, it's still a -3. So again, K will never be in parentheses. So here are general parent functions. This will work whatever the parent function was. We're just translating it based on f of x. So we're going to define our variables and discuss what they do. So in front of the function, if it's in front of it, this is an A value. So this has a vertical stretch of 4. Inside the parentheses is always my H value, and it's always the opposite of what I see, so I'm subtracting a -1. So H is -1, and it's going left 1. Okay. Example number 2. I see a number in front of my x, but I also see a number in the parentheses. If I have a b and an h, I must factor out the number that's in front of my x. So now I have a 3 in front of the x, so I'm going to factor out a 3, which means divide both of these numbers by 3. So I'm going to do the double parentheses here. What's left when I factor out a 3? X minus 4. And then I have a +2 at the end. So now I have a b, an h, and a k. The b value right here, I'm always going to take the reciprocal of it. So my b is 3. So let me write that down. My b is 3. But when I describe the transformation, I take the reciprocal of it. So this has a horizontal compression. So b is horizontal, and if the b was greater than 1, it's a compression. So it's the opposite of the vertical, the a value. So 3 causes a vertical compression of 1/3. X minus a +4. Remember, you always change the sign of whatever you see here. So H is a +4. It's going to the right 4. And K is outside of all parentheses. K goes up and down. K affects your range. So K is 2. The graph is going up 2. Okay, let's look at problem number 3. if you have a number in front of the function, that number is always a. So a is a -2. What does a -2 do? Well, remember that we look at the absolute value. Absolute value is 2. If it's greater than 1, it's a vertical stretch. So this is a vertical stretch. And honestly, this is where a lot of people make mistakes and they call it a compression because they think if it's less than 1, it's a compression, but it's only the absolute value. So this is a vertical stretch of 2, okay? Just because it's a negative just forces it to reflect over the x-axis. But the 2 causes it to stretch. So it's going to be facing over the x-axis. So like if it was a quadratic, then the quadratic is now facing down. But the 2 means it still got taller just facing down. It got more narrower facing down. At the end, remember that this is never in the parentheses. This is a -4. That is my k value. So k is a -4, and it means this graph is going down 4. Example number 4. A number in front of the x inside the parentheses means that is your b value. So b is 1/3. Remember that it's the opposite of a, so this is a horizontal stretch by how much you take the reciprocal. Taking the reciprocal means we're going to flip it upside down. So it's a horizontal stretch of 3. This also has a k value because k is never in the parentheses. K is causing the graph to go up and down. This is going to go up 1. Okay. So now go ahead and pause this video. Try number 1 and 2 on your own, and when you come back, the answers are going to be there. I'm not going to do a lot of explaining for the practice ones, but it's just for you to check what you're understanding. Okay, go ahead and check your work there. We're going to do the same thing for number 3 and 4. Don't forget on number 4, if you have a B and an H, you must factor out the B. Go ahead and pause this video. When you come back, you can check your work. Okay, go ahead and check your work here. The only thing I'm going to point out, because this is where I feel some mistakes are going to happen, is when I factored out a -2, that means I divided both of these by -2. So -4 divided by -2 was a +2. So it's like I changed signs here, but don't forget when I take the h value, I also change the signs. So h is really a -2 and the graph went left 2. Now we're going to focus in on the quadratic functions. This is the shape of a quadratic. It's x squared. The shape is a parabola. One of the points that I use a lot is I'm going to look at 0, 0. So when I talk about transformations, guys, I'm talking about this graph shifting to the left, to the right, shifting up, shifting down. If there's no a value, the shape is going to look exactly like this. But the a value will change. So what I always think about is, what's 1 squared? 1. What's -1 squared? 1. So I always know that the graph goes up 1/1 in both directions. And so if I have an a value, it's not going to go up 1/1. I still have an a, b, h, k. I no longer have this f right here that I've been putting. And the reason for the f previously was I was not attributing it to any specific parent function, just a parent function in general. So let's go ahead and practice some questions. So everything's going to be the same. Now I have an x squared though. So all these problems have a squared. The square doesn't change anything. So in example number 1, a number that's not in parentheses in front of the x. This is an a value. So this one, a has to be 3, which is a vertical stretch of 3. The number at the end, it's not in parentheses, and it comes after the x squared. If it comes after the x squared, this is a k value. So this k value is a -4. This means that that parabola is going down 4. That U shape is going down 4 units. So that graph would go down 4, and be narrower, okay? Example number 2. Remember that A is never in the parentheses. So this is your A value. A is a -4. Well, what's the absolute value of -4? A +4. So this has a vertical stretch of 4. Okay? Inside the parentheses with the x, that means that this is my h value, but we're always going to change the sign of the number we see there. So h is really a -1, and this graph was going left 1. Not in the parentheses, and it comes after the x squared. This is a k value, so k is a +2, so this graph would be going up 2. Okay. The next question, inside the parentheses, so if you compare these, this is an A because A is never in the parentheses. This is a B because it is in the parentheses. So this means that my B value is 1/2, which is a horizontal stretch of the reciprocal. So reciprocal means we're going to flip that fraction. 1/2 becomes it's a horizontal stretch of 2. Okay. The -2 at the end is not in the parentheses, and this means it's a k value. So k is -2, and this graph is going down 2. Example number 4. If I have a B and an H in the same problem, I must factor out the B. Now, when I factor it out, it still has to go in parentheses. So I'm going to put a 3 here. So we are going to see double parentheses, x minus 5. And I'm going to close my double parentheses and then square it. So all of that is still being squared. But guys, I have to put the double parentheses because if I don't, then I have an A value. And that is a B value of 3. Okay. The reason why I can't just put it in front of the parentheses is because if I put it in front, that means it's not being squared anymore. Okay. So that 3 is still part of the being squared. So B is 3, which means it has a horizontal compression of the reciprocal. Well, what's the reciprocal of 3? Well, right now it's 3/1 because every whole number is over 1. Take the reciprocal and it's 1/3. H is going to be a +5, so this graph is going to the right 5. Now you'll practice some on your own. Go ahead and practice number 1 and 2. Pause the video. When you come back, the answers will be there. Okay, hopefully you got number 1 and 2 correct. Now go ahead again, pause the video, and try number 3 and 4. Okay, there are the answers for that. Go ahead and check it. If you guys have any questions, you can always leave me a comment, and I can answer it. So now let's describe the transformation and then write the equation. So the blue one on both of these is the parent function. The main point is this 0, 0, and I know that it went up 1/1 in both directions. So that'll help me know if it's stretched or not based on is it up 1/1. If it's not up 1/1 in both directions, then it had a stretch or a compression. So let's see where this vertex went. It went to the right 1 and down 2. So it went to the right 1, down 2. So from my new vertex, right here, is it up 1/1? Yes. And so if it's up 1/1 in both directions, that means there's no stretch or compression. So if I have a right 1, down 2, that means my H is a +1 because the +1 went to the right 1. What causes it to go down 2? My K is a -2. Now, what happens to the H when I plug it into the equation? This is going to be x minus a +1. And because we see a parabola is the shape of this graph, okay? Because we see this U shape, that means it's a quadratic. which means I have to square it, and the k goes at the end. And we're going to write this as a function, so we'll write f of x equals. The second graph, remember that I'm going to start with 0, 0. Where did this new vertex, where did it go? 1, it moved over to the left. 1, 2, 3. So left 3, down 1. Does it have a stretch or compression? I go here, up 1, over 1. So no, it does not have a stretch or compression. So left 3, down 1. Left 3 means that my h is a negative 3. Down 1 means that my k value is a negative 1. Now don't forget that when I plug in the h value into the equation, the h value is always going to change signs because it's x minus a negative 3. So x minus negative 3 becomes x plus 3. Okay? You go ahead and practice a couple questions on your own. Go ahead and pause this video. Okay. Hopefully you were able to get both of these correct on your own. So now we're going to move into absolute value. Absolute value in quadratics, everything works exactly the same way. The only difference is the graph is not a U anymore, it's a V shape. And instead of parentheses squared, we now have absolute value bars. So that is an absolute value of x. So the absolute value of 1 is 1. The absolute value of negative 1 is 1. So again, everything works the same way here. So we have A, B, H, and K. So number 1, in front of the absolute value, this is an A value. This has a vertical stretch of 4. Inside the absolute value with the x is your h value, and we're always going to change the sign, so h is a negative 1, and this graph is going to the left 1. On the second question, because I have a number in front of the x, and I have a number after the x inside the absolute value, that means I have a b and an h, but I always have to factor this number out. Now, this is where it's interesting. My absolute value is still there. Now I'm going to take out the 5. So it's not double parentheses, it's absolute value parentheses. So I'm going to divide both of the numbers by 5. So the first one is x. What is negative 2 divided by 5? Well, if it doesn't divide perfectly, we can leave it as a fraction, or we can put it as a decimal. Okay. Now, if you check that, if I distribute the 5 back in, do I have 5x minus 2? I do. Now, notice that everything is still inside the absolute value because that is not an A value. If I don't put the absolute value in front of the 5, then the 5 is no longer an absolute value. So this means that I have a B value of 5, which means it's a horizontal compression of the reciprocal. What's the reciprocal of 5? 1 over 5. H is going to be inside the parentheses with the x, and I'm always going to change the sign, so it's a positive 2/5. So the graph is going right 2/5, or right 0.4, okay? Example 3, I only have a b value and a k value. I don't have to factor it out if I only have a b value. So this means that my b value is 3. Therefore, it's a horizontal compression of 1/3. Outside of the absolute value is my k value. Plus 4 means this graph is going up 4. The last question on this page. In front of the absolute value is a. This means that this graph has a vertical compression of 1/2. After the absolute value, this is your k value. Negative 4 means the graph is going down 4. Okay, now you should be able to do some questions on your own. Go ahead and do number 1 and 2 on your own. Pause this video while you try answering them. Okay, now you can try number 3 and 4 on your own. Pause it. Hopefully you got those right. Now let's go ahead and look at some graphs. So here is the transformations of graphs. So what does that do? So we start with 0, 0 again. This is my vertex, and I'm going to look at where my vertex moved. So this vertex went to the right 1, 2, 3, and up 1. So right 3, up 1. Therefore, that means that my h is a positive 3, and my k is a positive 1. Now I check also did my graph go up 1 over 1? Up 1 over 1, it did. So there is no a values. The a value is just 1. So we don't say that there's 0, a is 0. No, a is 1. That means it stayed the same size. If you multiply it by 1, it stays the same. So now we're going to write the equation. Now this is an absolute value, and we know that because of the V shape. So absolute value. When I plug in the h, I'm really subtracting it, so it changes signs. And then the k value goes at the end outside of the absolute value. This graph, here's my vertex. My vertex just went down 1, 2, 3, 4. It did not have any horizontal translation. So there is no h value. It did not move left and right at all. So this one only has a k value of -4. Which means that the h is 0. I don't need to write it. The x is all by itself in the absolute value. So you do have to have the absolute value. Okay. Now go ahead and try these two graphs on your own. And you can pause this video, and when you come back, you can check to see if you understood it. Okay. And hopefully you understood these and got these right. So hopefully this video helped understand transformations with regards to specifically quadratics and absolute values. If this video helped you at all, you can leave me a comment, give this a thumbs up. If you want more of these types of videos, go ahead and subscribe to my channel. Thanks and have a great day.